To discuss low energy dispersed dyes on polyester carpets or fabrics, it's very important to establish a baseline. And so what we have done is we've taken what we consider to be the industry standard colors: dispersed yellow 64, dispersed red 60, and a mixture of blue 56 and 77. Those dispersed dyes are standards of the industry. And in addition to that, we opted to go with the DyeStar products because there are some distinct differences and advantages, especially with the yellow component. And so with that, we have used a butyl isopropyl phthalimide carrier, odorless carrier, which also is the DyeStar product, and we have applied this to a filament polyester carpet. And in addition to that, we use the industry standard leveling agent, which is a end capped nonylphenol capped with coconut fatty acid. And we used a buffer slightly on the acidic side to perform these tests. And also we added a non-ionic wetting agent, which we normally would not use in exhaust dyeing, but to get the full impact of what the most prevailing conditions would show us in the diffusion rate of these dyes. And so what you see immediately when you look at this is that you begin with very little color going on, but mostly blue, that percentage that is going on at a low temperature. And as you progress, you see varying amounts of the three colors going on. At about 140 degrees, you begin to see a lot of blue uptake. About 160, you see the red. 180, you see a lot of red. 190, you begin to see three components, with the yellow lagging behind, and then as you reach an atmospheric boil, then you begin to exhaust the yellow. Now this is very typical, and this is what the standard is as far as we can see it in our industry. Now, looking at this a little closer in a little different way, same information, just tested and displayed a little differently. Here, what we have done out of an exhaust bath is measured the uptake of each individual color. So 3 different baths, but then we overlaid this dye uptake rate so that we have 3 lines: the yellow, of course, representing the yellow, the red, and the blue. And what you see is the yellow, of course, going on very slowly, and then as you approach these higher temperatures, you begin to see the uptake at a dramatic rate. The red begins lagging behind, but then goes on very quickly, levels off a little more, and then continues to exhaust as you approach an atmospheric boil. The blue is a little bit erratic, but it goes on much colder, and this is exactly what we see in this profile. And so now we have a fingerprint of these dyes to look at. So if you begin to look at this, if this were any other fiber but polyester, you would of course not be happy with these results. If you didn't use, for instance, this yellow, if you used some of the cheaper import material, you would see a line even more like this. If you use dispersed blue 56 instead of the mix, you would see it go up and over like this. So this is very typical, and this is the standard of the industry. What we have done is something dramatically different and new. We have developed a dye system, and when we compare it to this, immediately the thing that you see is that the rate of uptake is much different, first of all, because you have a much higher percentage of color in these temperatures before you reach an atmospheric boil. You also see the yellow begin exhausting with the red and with the blue in a very controlled fashion, tone on tone, much like what you would expect to see with nylon. Now, again, we're using an industry standard system, and this system is the same, but we did not use leveler. So here you have a leveling agent, here you have no leveling agent, because even this result would not be quite as good without leveling agent. But here the system itself is vastly improved, and we feel like it eliminates the need for a leveling agent. So what you see is tone on tone buildup, and this is very, very important. And we think if you look in this area where you have, even at 190 degrees, you have the same cast, just slightly weaker. And this is a critical difference when you're talking about continuous dyeing, when you're talking about steaming conditions that may not be perfect, and moisture conditions that change the rate of heat transfer. This is significant, as is this. Now, looking at this, let's look at it a little different way. Now here we're back on the graph, but again, a different test, different method, but we see the same thing. Here we see a profile, which a perfect profile would be a straight line, almost perfect profile with all three colors behaving almost exactly the same without leveling agent. Here with leveling agent, we see this erratic pattern that we have learned to live with. And so we think this is very, very significant, and we think that this is critical to achieving good levelness and color uniformity with ease of control. Now let's move on. Of course, color application is critical to achieving color uniformity and levelness, and we have demonstrated that we can control the rate that these colors go on. But the second leg of levelness is your transfer or color movement, and what we've done here is another old-fashioned test to look at how much color we can transfer. Again, we're going with the same industry standard system and description that we've talked about. The only difference between these two tests is that this includes leveling agent, this has no leveling agent. So let's walk through this. In your industry standard system, you have a dyed piece, which we dyed. We cut half of it off, which is here, and we put it in a bath with white, and we run this at atmospheric boil for 15 minutes. Now the reason we did that, the old transfer tests were typically 30 or 45 minutes depending on your dye cycle, but with most of the fabric being continuous dyed, at least in the carpet industry, we felt like this is a better, more meaningful and relevant test. So we have 15-minute transfer, and the first thing that jumps out at you is this has a green cast now, and this is orange. Now these two colors combined would give us this color, but we're transferring orange, which is not what you really want. You want it to transfer on tone. Here we have the original, here we have half of this, and here we have transferred to white, and you can see the difference in cast of these two. You have transferred blue here. Now why is that so critically important? Well, if you remember, in the exhaustion curve, your blue jumps on first and then levels off. So any unevenness you have as this blue begins to diffuse into the fiber more rapidly, you need to be able to adjust any non-uniformity with transfer, or at least to the extent you can transfer that color, you will achieve color uniformity. This we consider to be vastly superior to this. Now we have described this as an ECO system in our very brand name, as we call this Levichrome ECO. And as you look at this, it needs to be walked through because these side-to-sides are not directly comparable to one another. What we've done, if you look at this dyeing, this is our dyeing, this is what's left in the bath. And this is with no carrier. So this is same industry standard system again, without leveling agent, no carrier. And of course the exhaustion is not that good, but the first thing that you see it is on tone. Now because of the huge disparity in the way these systems work with carrier, we are comparing no carrier here to 1% carrier. Because with no carrier you begin to have to step through a long series of varying amounts. So what we've done here started with none, started with 1% here. Now with a conventional system, what you see, you almost have a purple shade with your yellow trailing behind with 1% carrier. And again, this is the industry standard odorless carrier, the butyl isopropyl phthalimide from Dystar. This is typical. Now on this side we step up to 1%, which this exhaustion compares to this. So these two are the same, with the exception that we do not use leveler in this system. So here we have 1%, this is your color, and this is the dye that remains in the bath. Here we're at 2%, so this is 50% less carrier than this. So, or this is double the amount, whichever way you'd rather state it. Here we see the yellow going on now. With that difference in carrier, when you double the carrier, your yellow begins to exhaust dramatically. And we see kind of a pink residue left in the bath, a little bit of blue, a little bit of yellow, and some red. So this is good. It's good exhaustion. That 2% carrier would be okay in that setup. Now here we're going to 2%, and this compares to this, and we see very good exhaustion, just very little color left in the bath. And here we're looking at 3%, and you begin to see a little bit of difference in behavior. And what happens with this system, as you continually add carrier, if we went up to 6% carrier, we would have a lot of color left in the bath, because when you open this fiber to put color in, you go to a tipping point where you begin to pull color off. So what we're looking at here is we've probably passed the point where we are optimum on our carrier. But the behavior is significantly different, because you see this 2% versus 2%. And we didn't expand this much because what we have found is everybody does not use the same carrier. Some of the carriers are bastardized with peg esters and things to weaken them down, and every one of those additional chemicals causes some change in behavior, so you can't capture every carrier. So we went to the straight unadulterated carrier, and we made this display, and this display is accurate on this fiber, but also when you change fiber systems you begin to get differences. But what we see in all fiber systems, and independent of which type carrier that it's used and how it's been adulterated, is we see this trend where we exhaust color on tone using less carrier. And this is the reason we call it an ecosystem. Now, a lot of people, the first question they ask is, what does it cost? Well, my question is, what does it matter? Because if you can reduce your carrier, let's say you're paying $1.50, $1.60 for carrier, and you're using 3%, let's say for instance, and you can reduce that to 1 or 2%, and you can also eliminate your leveling agent completely, which means with the reduction in those two you can also reduce your antifoam dramatically. And because of this system being insensitive to pH, completely insensitive, you reduce your amount of buffer. Suddenly you have enough chemical savings so that you, in your typical light shades, it's like getting your dye free. You've saved more money than as if you had no dye cost. Plus you have made a gigantic environmental stride. So we with confidence call this an ecosystem, but it's also an economical system, because we think that that these reductions in in chemical usage, you just want to save money. You really don't care where you save it. And if you can save it in chemicals, that's better. If you can get higher exhaustion, again, that's an ecosystem. We've gone in and down around all types of fastness testing. We've looked at nitrous oxide, we've looked at ozone, we've looked at wet bleed, we've looked at every aspect of fastness. The first question usually, and the reason for this being the industry standard in the colors that are selected, is light fastness. And so what we did, we took 3 shades, and we took these first 3 shades. We did not go into testing and retesting to try to skew results, but we made a very light beige, which we call beige A. We made the color with the Levichrome colors, matched it with the conventional, and here we see 4-5 at 40 hours, 4 at 60 hours on both of them. Beige B, which was a different shade of beige, we have a 4 with the Levichrome and 4 after 60 hours. 4-5 on the conventional system, which is a half a point better. 4 the same after 60 hours on each. And then we made a taupe color, which was a combination of all 3 colors in about the same ratio. And we have a 4-5 with the Levichrome, 4 with conventional at 40 hours, 4 and 3-5. But we, would not from this suggest that we're going to have superior light fastness, but what we do see is equal fastness. So if we're equal in fastness and we gain the other properties and savings that we believe we will gain, then we would call this a win.